Hey everybody, it's Mr. Anderson here. Welcome back to another edition in geometry. Today we're in chapter 10. We've been talking about triangles, it seems like forever, and today we get to start talking about circles. So circles and circumference is what we're going to talk about today. Our objectives today, identify and use parts of circles, and secondly, to solve problems involving the circumference of a circle. All right, let's start out with what a circle is. Okay, so a circle, as you're probably aware, looks something like this over here. And the way we define that, we say a circle is the set of all points in a plane that it's equidistant, which means have the equal distance from the center of the circle. So here the center is F, and so from F to M, there's a point out here on M. And if you continue around the circle, the next point over, which might be very, very close, is the same distance. And so there are so many points that it makes a line and creates a circle here. Okay. All right. So the way we name a circle is we name it by the center point. So when we name a circle here, this circle, the example that I've got for you here, we could either just write out the word circle. So we could call this circle F. That's one way we could name it, or we could use this. There's a that's not the greatest. That's supposed to be a little circle there with a dot in the middle. Okay, that's the symbol for a circle. We could just make that symbol and call it circle F. So with math, mathematicians always like to have little symbols for everything. So this is the symbol for circle because we don't like words. And so you could either say circle F or circle F using that little symbol there. All right, so there are different segments in a circle. All right, first of all, the radius. The radius, and by the way, the plural for that is radii. That's more than one radius. A radius is just a segment that has an endpoint at the center and on the circle. So if you look here the center is C. And so if you go out here, the end of this segment would stop at F. So from C to F is a radius, okay? Also from C to E is a radius, and from C to D is also a radius. All three of those are radii, okay? So a radius is just from the center point to the circle itself. A chord is a segment where both endpoints are on the circle. All right, so what we typically think of as a chord is like AB here. Notice AB, one endpoint is on the circle and the other endpoint is on the circle, and that's where the segment stops. That we typically think of a chord, but also from D to E is a chord, okay? So that is also a chord. The endpoint is on the circle and the other endpoint's on the circle. Well, why do we not normally think of that as a chord is because that's the next one here. It's a diameter. We usually think of that as a diameter, which a diameter is really just a chord that goes through the center, okay? And so that's a diameter is when it goes straight through the center from one side of the circle to the other side of the circle, okay? So those are some terms that we need to know. All right, first of all, name the circle and identify radius. Okay, so remember how we name a circle? In this case, we go, oh, here, look for the center there, that's E, so the name would be circle E. Okay, that's what we would call this. It's circle E. And then identify a radius. Well, a radius would be anything that goes from the center out to the edge. And so there are actually two that we could name here. One would be EB, or we could call it BE if we wanted to, would be one of them. And the other one would be from E to D. So we could call it ED or DE. So those are the two different radii that we could name on that one. All right, what's next? Let's identify a chord and a diameter. All right, so in this example, we look at this and there are actually three chords. The one that we typically think of as a chord would be from W to Z. That's kind of what we normally think of. And so WZ would be a chord. I don't know. So that would be a chord. And that doesn't really look like a W there, does it? There we go. But also, other chords could be WY and XZ. Okay, so WY and also XZ. Those are also chords. Okay, so those all are chords. And what else did it say? What's a diameter? So what would be a diameter? Well, in this case, actually the two other chords that we named here are also diameters, so WY and XZ. So both of those are diameters. Okay, hopefully this isn't too difficult right now. All right, all radii of a circle are congruent. Okay, so that's kind of the definition of a circle is, you know, if you go from the center point out to the circle here, the edge of the circle, that's the radius, and so all those points are the same distance away from the center. So therefore, every single radius that you have would be the same. So from F to A would be the same as from F to N, and it would be the same from F to T. And if you had a line from F to C, it would be the same distance from F to C. Okay, so all radii are congruent, and so therefore, what happens here is when we look at the relationship between the radius and the diameter, you go, well, let's say here that FA, that's a radius. What if we called that? What if that was 3? What if that was 3? Well, since I said all the radii have to be the same, that means from F to T would have to be the same. Would also have to be 3, right? And so what's the diameter? Remember, the diameter is all the way across. That would be 3 plus 3, or the diameter would be 6. Okay, so that means AT would be 6. That's the diameter. Well, how does that compare to our radius? It's double our radius, right? Because we took 2 radii and added them together to get that. So this is just saying that if you want to know the radius and you know the diameter, all you have to take the diameter, divide by 2, you'll get the radius. Or if you know the diameter, you can multiply it by 1/2 to get the radius. It's the same thing. And if you want to find the diameter and you know the radius, you just multiply by 2. So just remember that the radius is half the length of the diameter, so whichever one you have, you can easily convert back and forth between those two. Okay, so for example, here's an example. If RT is 21, so we know this whole thing is 21. Okay, that's 21. What's the length of QV? Well, if you look at this, you say, well, QV is this distance here. Well, how do these relate? Well, we could say, well, we could probably approach this 2 different ways, but we could say, well, you know, if I know RT, well, RT is the diameter, so VT is the radius. I could just take 21 and divide by 2, which gives me 10.5. So that could be the length of VT, which would be a radius here. Well, VT is a radius, but VQ or QV is also a radius of that same circle, so therefore it has to be exactly the same as VT, and so that means that QV would also equal 10.5. Okay, does that make sense? So even though this is a different line, once we found that the radius on this line here, we know that this radius has to be the same. You could have also thought of it that RT is a diameter, it's 21, and all diameters are also the same. So QS would have to be 21, and then you could divide that by 2 to get QV. Basically the same thing, just a little different way. Likewise, if you're given the radius, if you knew that VT was 5, then if you wanted to find QS, you could just double it to get 10. So again, just back and forth, either divide by 2 or multiply by 2. All right, just quickly, some things about circle pairs. If you have a couple of circles, first of all, remember before when we were talking about different shapes, not circles, but polygons, and we said they were congruent if the size and the shape was exactly the same. And basically that's the case here too, but in all circles, their shape is the same. No matter what circle you have, the shape is always the same. So in this case, the circles are congruent if they have the same radius. Okay, so if JK equals GH, they're congruent. If they're not congruent, they're similar, okay, because all circles are similar. All right, so they're all the same shape. They may not have the same size, but remember, similar means the same shape, but not necessarily the same size. So all circles are similar. And then concentric, you might not have heard this word before, but concentric means it has the same center. Okay, so that just means you have two circles here. Concentric circles have the same center. And so it would look something like this. So, all right, also, if you have a couple of different circles, they could intersect. Okay, so here's a good example where we could use some things that we've been learning here. And we've got two circles that intersect, or they cross over each other. But we can use kind of some logic to figure out some things here. So the diameter of circle X is 22. So here's circle X. Circle X is this big circle right here. So the diameter is 22, which means that's all the way across. So that's from point Z all the way off over to here. Now there's no point here, but that's what that would be. Well, what do we have in circle X? We've got from X to point Z. We only have the radius. So if the diameter is 22, I'm going to draw this here. That means this part is 11. Does that make sense? Since the whole diameter from Z all the way across is 22, from X to Z is 11. Okay, what else do we know? Well, we know that the diameter of Y is 16. Well, here's Y over here. It's this other circle. That diameter is 16. Well, again, we don't have the whole diameter there, but we have from Y to W. We have that one, and that is the radius, so that's half, right? Like we've been doing. So that is 8. Okay, so we know that the radius is 8 because it's half of 16. And it also told us that WZ was 5. So from W to Z is 5. All right, we want to find XY. Well, we've written in the stuff that we know, so let's see what can we figure out. Well, XY is the total length of this. So, well, what can we do? Why don't we just find like these missing little segments here, and we can do that pretty easily by just kind of looking at what we've filled in here already. Well, if you know from W to Y is 8, and this part is 5, what would have to be left over here? Well, 8 minus 5, or 3, right? And over here, if you know from X to Z is 11 and this part's 5, well, what's left here? 11 minus 5, or 6. And so then now you know that this is 6, this is 5, and this is 3. And so if we want to find XY, it's the whole thing. So we just do 6 plus 5 plus 3, and that would equal 14 units. Okay? Is that, hopefully that makes some sense there. It's mostly just kind of logic that you're using to think through that. All right, circumference. The circumference around a circle is the distance around the circle. So here's an example of a circle I've got here. So the circumference would be, you know, if you started at R, you're going all the way around the edge, all the way, you know, past S, past T, past Q, all the way back to R. Okay, so that's the circumference. It's all the way around the edge of the circle. If you remember before when we had polygons, we talked about the perimeter. The circumference is just the same thing as perimeter, except for circumference is for circles. Okay, so it's just the distance around the circle. All right, now here's something that's really kind of interesting. Pi. Oh, everybody's all into pi. Yeah, Pi Day. Ooh, when are we going to have Pi Day? Yeah, let's have Pi Day. It's great. Oh, yeah, pi, pi, pi. Okay, where does that come from? Okay, this is where it comes from. If you don't remember this, the big C here is for circumference, and D is the diameter. We've just learned about circumference and diameter. So pi, all pi is, it's just you take the circumference of a circle and you divide it by its diameter. So remember, the circumference is all the way around. If we take that distance and divide it by the distance from R to T, it will give us pi every single time. No matter how big the circle is, no matter how small the circle is, if you take its circumference, did I just do that? If you take its, that's a really straight line. Wow, look at that. If you take its circumference and divide by its diameter, you're going to get pi every time. Okay, so that's kind of cool. And the kind of another way to well, actually, if you remember, Pi is a decimal that goes on forever. It never terminates, it never stops, and it never goes into a repeating pattern. And remember, it's approximately 3.14, 159, and so forth. Okay, it keeps going there. You may have memorized that to 100 decimal places. I don't know. But it's somewhere in that neighborhood there is what pi is, which means that if you were to take the distance of the diameter and kind of take that distance from r to t and put it around the outside, it would go around once and stop, and you put it a second time and it would go around until it stopped, and a third time until it stopped, and then you'd have a little bit left over. That's the 3.14, 3 times and then a little bit more around the edge of the circle there. Okay, so that's kind of cool. So let's get into what we actually really need to talk about here. That was just fun stuff. Okay, so if you have the circumference divided by diameter, if that's what pi is, well, we can come up with a little formula here just using some algebra. I'm going to multiply by d over 1 to get the d's to cross out here, and go times d over here, and what do I have? Circumference equals pi times diameter. That may be a formula that you have memorized perhaps, or at least heard about somewhere. That's where the formula comes from, the fact that circumference divided by diameter is pi. And so this formula down here is what we can use for the formula for circumference. Now, you could also use circumference equals 2 pi r. You might have heard that one before. It's really the same thing because the diameter is the same thing as what? 2 times the radius. That's why it's the same formula. So whatever way you remember it is fine. I kind of like using pi times diameter. It seems a little simpler to me. So pi times diameter, or 2 pi r. So let's see how we could use that. All right, a series of crop circles was discovered in Alberta, Canada on September 4th, 1999. The largest of the three had a radius of 30 feet. Find its circumference. Okay, so let's just kind of draw this. Don't make fun of me because my circle may not be very good. I'm trying to do this by freehand. That's not bad. And so there's the circle. The radius is 30 feet. So we're going to go here from the center out. That's 30 feet. Okay, so find its circumference. Do you remember what the formula is? Circumference equals pi times diameter. All right, well, what do we know? We know the radius. So if we wanted to, we could use the other formula here. If you wanted to, it might be easier just to memorize one or the other and then just adjust it. But if you know that the radius is 30, what's the diameter going to be? 60. It's going to be double, right? So we could just say the circumference equals pi times 60. And I think, hopefully, rats. Okay. I had it all planned out with my calculator and everything, and it's supposed to work here. There it is. All right, good. I don't know why it was taking so long. So, anyway, so we'll just type in here 60. I'm just going to go 60. And then second function, and I think this is my pi here. It's kind of hard to tell on this. Yeah. And so that's going to be about 188. We'll go 188.5 on that one. So 188.5. So the circumference is approximately 188.5 feet. Okay, so all we had to do is, get the diameter, plug it in. If you use the radius, then you're just going to plug in 30 here and go what? 30 times 2 times pi, which is the same thing, and it's 188.5. You can also do this the opposite way using that formula if you already know the circumference. We know the circumference is 64.5. So using that same formula, circumference equals pi times diameter, if we know the circumference, we can just plug that in for C here. So 65.4 equals pi times diameter. We just plug it in for the C. Well, how do I find my D then? Well, basic algebra, divide by pi, because these pi's will cross out. and we'll divide by pi over there. So in this case, now we have d, or the diameter, will just be 65.4 divided by pi. And so, I don't know why my calculator is being so finicky today. Okay, I'm just going to do it manually since I can't get that one to come up. So this is just going to be 65.4 divided by pi. And so what I got in this case, okay, let's slow down here. Let's just try to get back. Okay. And so what I've got here then is that the diameter would be approximately 20.8 feet. And then since we're also trying to find the radius, remember that's just going to be half of this. And so then I just do, so if that's my diameter, then I just do 20.8 divided by 2. And so that'll give me 10.4 feet for the radius. Okay? Okay, so pretty simple, except for getting the calculator to work correctly. All right, then inscribed and circumscribed. Here's an example that we're going to talk about. And in this case, this is a polygon, and we would say it's inscribed in a circle because all of the vertices, B, C, D, and A, they all lie on the circle. All the vertices of the polygon lie on the circle. So we could say it's inscribed inside of that circle. Another way that that could be said is a circle, from the circle's perspective, it's circumscribed about the polygon. So it's kind of, when it's circumscribed, it's kind of around the outside of that. Again, where the vertices the vertices of the polygon are touching the circle there. Okay, so let's look at an example of what would happen here. The circumference, find the circumference of the circle if the square is inscribed in the circle. So basically what this is telling us here is this square, the vertices of the square are touching the circle here, the edge of the circle. Okay, well, how could we find the circumference? Remember, well, if we're looking for circumference, circumference equals pi times diameter. So what do we need in order to find the circumference? We need to know the diameter. Well, if you notice here, it's drawn in for us already that in this square, if we draw a line from the vertex over here to this vertex, that's the diameter of the circle, okay? And so really what we've got here is we've got a little triangle, and if we could just know something about triangles. Hey, we've been studying triangles. Hey, we know what to do. Look, it's a 90-degree triangle. It's a right triangle. And so if we know two sides and we want to find the third side, we can do the Pythagorean theorem. Remember? A squared plus B squared equals C squared. And so in this case, remember our C squared is the diameter, that's the D. So I'll just use D in my example here. A and B are the 3 and the 3. So all we have to do is 3 squared plus 3 squared equals the diameter squared. Well, this will be 3 squared is 9 and 9. So D squared is 18. Remember how we undo the square is take the square root. And so the diameter here would be the square root of 18. I'm not even going to try my calculator online. I'm just going to go to this one. Square root of 18, and so the diameter here would be approximately 4.24. About 4.24 is this distance here. So to find the circumference, we just plug that in. And so circumference equals pi times 4.24. And then just type that in our calculator. And I get about 13.33, we'll say. So the circumference is about 13.33 inches. Okay, good. All right, well, hopefully that wasn't too bad, with the exception of my stupid calculator not working. But appreciate you being here for section 10.1, some stuff with circumference. and pi and all that good stuff. So appreciate you being here. We'll see you next time in section 10.2. This is Mr. Anderson saying see you later. Bye.